Good morning, everyone. I am Frederick Salimi. I am director of the PMCO Pro. Today, we would like to show you how we manage safety critical element for the whole life cycle of a project. This course takes 1 day. We will give you access to EPC 365 for discussion with your trainer for 1 year. After successful exam and a score of 80/100, you will get certificate of the Academy. This program is well suited to plant managers, HSE engineer, process safety engineers, and the objective of this course is to give a practical understanding of life cycle management of safety critical elements, safety and environmental critical elements for your installation. A brief description about myself. I have a master degree in safety and reliability, maintainability and availability from École Centrale de Paris. I have also industrial process control and instrumentation from Créteil Technological Institute in France, and I have applied physics from Pahlavi University. I have several qualifications, for example, accident investigation in Houston, QRA in UK, and I was the lead safety engineer in several projects worldwide, and I worked more than 10 years for Total, and also I work for Technip more than 5 years, and Coverner is more than 5 there in United Kingdom. So I am very familiar with these safety critical elements and how to manage it for the project and the life cycle of projects. The safety critical element are systems whose failure could lead to a major accident, and also those systems whose failure reduce the ability to control, mitigate, or escape from major accident. How we identify them? By Bowtie analysis when it exists, when measure taken into account in risk reduction workshop in detailed risk assessment, or measure resulting from alarm demonstration of unacceptable and critical risk. Bowtie and layer of protection. If you see here about Bowtie is you have an undesirable event. There are certain hazards, there are certain causes, and if these barriers fails, for example, this layer of protection fails, you will have the loss of containment, and if there are the barriers for control and mitigation does not work, you have explosion, toxicity, etc. The performance standard normally is something like this, and you have to define clearly what is the functionality for a system. For example, this is for the fire water pump, what function it should have, and then we have to give the reference to all the documents related to this functionality, and then put the means of assurance, for example, in the design, in the construction, commissioning, a startup, what measure we put in place, and we have to give this. We give in our training courses the example of performance standard for each critical system, and we discuss it in detail later. Safety critical elements normally as we said, they are systems whose failure could lead to a major accident, or system whose failure reduces ability to control, mitigate, or escape a major accident. Normally, we have 4 categories of the barriers. The first one is means of prevention, such as structural integrity and pipeline integrity. Means of control, like flammable gas detection, ICSS is the system. Means of mitigation, such as fire pump, fire ring main. And finally, means of escape and rescue, such as internal communication, external communication, etc. Table of contents of safety critical element lifecycle management should cover about document verification. Because it is a formal document, the roles and responsibility for signature should be given about responsible, accountable, and the people who endorse the documents with their signatures and the date of signature for implementation. Reference documents such as detailed design documents, company document, vendor document, and international code and standards. Abbreviations, list of holds, if there is holds which are requires more time, they should be given there, and local authority documentation such as RH should be given in this document. Responsibilities of actors, responsibility of inspection department, maintenance department, operation, technical department, HSE, and also for implementation and control, management procedure, performance standards, implementation, computer assisted maintenance and management, management of change, test delay, and inhibition. About description of integrity of execution aspect, about fail test, priority of control and test, review of life cycle management. For example, if there is a changes in the installation that requires update of the HSE case or étude de danger, you should update the life cycle management document. Performance standard about operational verification, minimum inspection and maintenance requirement, modification verification, resource and competency requirement, and finally modification register. Action plan, all the action plans with the name of the actionee, the due date, and the status, if it is open or closed, for inspection, maintenance, training and competency, failure action, anomalies. And finally, the register. The register should be given for training register, failure register, anomaly, etc. So as I said, you will have the certificate of the Adobe Academy after 12 months working in our workspace, in your trainer workspace, and respond to the discussion. We have the certificate of education from ISO and also innovation. Thank you for your attention. You get more information about safety critical element in our website in French, pmc.services, and our website in English, epc365.com.
The CSB found that lack of winterization procedures also contributed to a massive fire that took place in 2007 at the Valero refinery near Sunray in the Texas Panhandle. The fire occurred in a unit that used large amounts of high-pressure liquid propane. Years earlier, the unit had been reconfigured, creating a dead leg, or a section of piping without any flow of liquid. Dead legs are particularly vulnerable to the hazards of freezing, and the dead leg at Valero was blocked on one side by a leaky valve. CSB has established key winterization safety lessons that facilities should follow. Facilities should effectively identify and address the risk of freeze-related hazards to piping and process equipment through process hazard analyses, management of change evaluations, pre-startup safety reviews, and operating procedures. Create and implement a winterization checklist to ensure that their plant and process systems are ready for cold weather. Establish a formal written freeze protection program. Survey piping systems for dead legs and ensure they are properly isolated, removed, or winterized. And systematically review process units, including infrequently used piping and equipment, to identify and mitigate freezing hazards. January 22, 2018, the Pryor Trust gas well in Pittsburgh County, Oklahoma. The well was operated by Red Mountain Operating, LLC, which contracted the Patterson UTI Drilling Company to drill the well. In order to change a drill bit, crew members removed the drill pipe from the well. Approximately 3.5 hours later, a blowout and rig fire occurred, killing 5 workers. Although there is a large body of guidance and recommendations on the design of alarm systems for hazardous operations, none are specifically targeted for the drilling industry. As a result, the CSB made a recommendation to the American Petroleum Institute to develop a standard on alarm management, specifically for the drilling industry, that addresses drilling's unique dynamic environment and provides guidance on implementing a state-based alarm system for different operating modes. There were 2 exit doors from the driller's cabin, but both of those exit doors were blocked by flames after the gas and mud ignited. The CSB concluded that had the fire rating of the driller's cabin been ensured for a minimum time, with emergency escape options from the floor or from the back wall, there could have been a better chance for the workers inside to have survived this